Hello guys, welcome back to my channel. Today we're going to be exploring the concept of volume, but to explore the concept of volume we're going to go back and look at area. Area is the amount of surface covered. So here we have figure ABCD. The area of ABCD is the amount of space that is covered, which is in here. Now to find the area of ABCD, what we do is to take a unit square. What I mean by unit square is a square whose dimension is 1 unit by 1 unit. So let us imagine that this is a centimeter square. The dimension of the square would be 1 centimeter by 1 centimeter. So this becomes 1 centimeter times 1 centimeter, and this is how it becomes a centimeter squared. So the area basically is the amount of centimeters squared that we can stock onto this object here. So let's see how much it takes. So this is 1. That's 2. That's 3. If we count the amount of centimeter squares, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 of them. So the area of this becomes 18 square centimeters. What do I mean by that? It means that we have 18 squares whose units are 1 centimeter by 1 centimeter. So we couldn't actually say 18 centimeters squared, because that would actually mean 18 centimeter by 18 centimeter, which this is not it. This is 1, 2, 3, 3 by 1, 2, 3, 4, 5, 6. So to easily calculate the area, instead of counting all the squares, we can simply say it's going to be 3 centimeters multiplied by 6 centimeters, which actually becomes 18 squared centimeters. Of course, and that is why to find the area of a rectangle, we use the formula length times width. Now, a two-dimensional figure, as you can see over here, cannot have volume, because volume is the amount of space that an object occupies. This cannot have any volume because this is flat. So in order to get volume, all we have to do is to take the two-dimensional figure and to project it, which produces a three-dimensional figure, as you can see on the right. Now, because it's a three-dimensional figure, you can look at the bottom here, which is the base, which would have been the figure here on the left, but this has a height now. So we would have projected this square forward. Now, as you can see, we have an extra dimension here, height, which is 1 unit. So this is what is referred to as a unit cube. And the dimension of this cube is 1 unit by 1 unit by 1 unit. So I would have 1 unit times 1 unit times 1 unit, which is 1 unit cube, which of course by laws of indices, unit times unit times unit would give me unit cube. So we have 1 unit cube. So to get the volume of any figure or any object or any three-dimensional figure, what I have to do is decide how many of these unit cubes that we can stack together to produce that object or that figure or that three-dimensional figure. So let us say that this three-dimensional solid was 1 centimeter by 1 centimeter by 1 centimeter. The volume of this cube, which is a unit cube, would be 1 centimeter times 1 centimeter times 1 centimeter, which by laws of indices will be equal to 1 centimeter cube. So when we say a unit cube, we mean a cube with dimension 1 unit by 1 unit by 1 unit. And this is the amount of this that we can stack to produce a three-dimensional figure becomes the volume of that figure. On screen here on the left, we have a square, and we can see that we have all the sides there. When it becomes a three-dimensional figure, or when we project it, these can no longer be called sides. They become edges, as you can see that they form the boundaries of the faces, so they are referred to as edges. So when it's a square, it's a side, but when it becomes a cube, it now becomes an edge. Now we want to find what the volume of this cube is. As we said before, the volume is the amount of space that the cube occupies. So just imagine that this thing is blank, and we're going to look at the space that we're talking about. So here we go. As you can see, that is the space they're filling up. So the volume at any point is the amount of space that this cube occupies. And there we go. Now initially, when this goes down back to 0, it just simply becomes a flat surface, which actually means that there's no volume, because volume, a two-dimensional shape, cannot have volume. For us to get volume, we have to project it. So when we give it a height, there we go, then that has volume now. So what we want to do is that we want to determine the amount of units cube that we can stock into this. And bear in mind that since the unit cube would be 1, the volume of a unit cube is 1 centimeter cube or 1 units cube. So how do I know how many I can stock into the surface here? Now the dimension of this cube is length by length by length. So how many units cube could I stock in there? So this is going to become length times length times length. So the volume of a cube becomes length cube. So once we have the length, we can simply determine what the volume is. Here's an example of a typical question. Determine the volume of a cube below. Now we only need a single edge because all the edges have the same length. All dimensions are the same. So we can go right ahead to the formula and say that the volume V is equal to L cube. So the volume would be equal to 8 cube, which would break down to give me 512 cubic centimeters. All right, and what this means is that we have a box that can be filled by 512 unit cube. In other words, it takes 512 cubes that have a dimension of 1 centimeter by 1 centimeter by 1 centimeter to fill out the space occupied by this cube here. Here's a second example, guys. The volume of a cube is 27 cubic centimeters. Determine the length of an edge of the cube. So we simply start by writing the formula, which is volume equal L cube. The volume here is 27, so we're going to have 27 equal L cube. Of course, we want to find what L is, so we need to get rid of the cube. And the opposite of a cube here would be the cube root. So we're going to have to find the cube root of both sides. Now the cube root of 27 is 3, because you multiply 3 by itself 1, 2, 3 times to get 27. So this becomes 3 equal L. So therefore, the length is equal to 3 centimeters. Don't forget the unit.